Imagine this. You create an AI. Then that AI helps you build a better AI. The new AI becomes better at research. So it helps create an even better version of itself. And then that version does it again. And again. Sounds like science fiction, right? But here's the strange part. Some of the pieces of this idea are already appearing in the real world. We're not talking about a super intelligent machine taking over the planet. Not yet. We're talking about something much more interesting. AI is beginning to help humans improve AI itself. And if that loop keeps getting stronger, it could completely change the speed of technological progress. For decades, improving AI was mostly a human job. Researchers designed experiments. They wrote code. They trained models. They studied the results. Something failed. They tried again, and again, and again. It was a slow process. Sometimes it took months, sometimes years. But now, something has changed. AI can participate in the process of creating AI. Modern AI systems can write and debug code. They can analyze experiments. They can search through enormous amounts of information. And they can help researchers explore possible improvements. Researchers are already building systems designed to automate parts of scientific research. So the question is no longer simply, can AI do our work? The more interesting question is, can AI help improve the machines doing the work? And this is where things get really interesting. Imagine giving an AI one simple goal. Make this AI model better. The system examines the model's code. It finds something inefficient. It suggests a change. Then, it runs an experiment. Maybe the experiment fails, so it tries something else. That fails too. Then it finds an approach that works. And it keeps going. Now imagine doing that hundreds of times. Instead of one human researcher running a handful of experiments, you could have an AI system running experiment after experiment. This isn't just theoretical anymore. Researchers have already demonstrated early versions of this idea, including AI coding agents that can run large numbers of experiments to search for improvements in model training. But there's something important to understand. The AI isn't independently redesigning the entire future of artificial intelligence. Humans are still involved. Humans choose the goals. Humans provide the computing power. Humans create the environment. And humans decide whether the results actually make sense. So, we are not living in the world of fully self-improving AI. We're seeing the early stages of something that could become much bigger. But what does AI improving itself actually mean? There are different levels. At the simplest level, an AI can improve its own answer. It can check its work, find a mistake, and try again. A more advanced system can modify its tools, its code, its prompts, or even its workflow. Then there's AI-assisted AI research. That's where AI helps humans design experiments, optimize algorithms, and develop new models. And then there's the extreme version, recursive self-improvement. This is the idea that really gets people's attention. Imagine an AI that can design an improvement to itself, build that improvement, test it, and then use the improved version to create an even better version. Then that version does the same thing, over and over and over again. That's where the idea of an intelligence explosion comes from. But here's the reality check. We are not there yet. Today's AI systems still have serious limitations. They make mistakes. They can produce convincing but incorrect information. They struggle with long-term planning. And they still need humans to guide and evaluate important research. So why is everyone suddenly paying attention to this? Because AI is getting better at the exact tasks involved in AI development. Coding, debugging, testing, research, data analysis, experimentation. And these abilities can reinforce each other. Think about it. Better coding AI can help build better research tools. Better research tools can accelerate experiments. Better experiments can lead to better AI techniques. And better AI techniques can create even better coding and research systems. That's a feedback loop. And the faster that loop becomes, the faster AI development could potentially move. But there is a problem. AI can't simply think everything into existence. Imagine an AI discovers a revolutionary new computer chip. Someone still has to manufacture it. Suppose it discovers a new medicine. Someone has to test it in the real world. Suppose it creates a better AI architecture. Someone still needs enormous amounts of computing power to train it. And that requires chips, electricity, data centers, cooling, and money. A lot of money. There are also deeper problems. How do we know an AI's scientific conclusion is actually correct? How do we make sure its experiments are reliable? How do we stop it from optimizing for the wrong goal? And perhaps most importantly, how much human oversight will still be necessary? These are questions researchers are still trying to answer. Now, let's imagine something. It's the year 2030. This is not a prediction. It's a thought experiment. Imagine an AI research system capable of performing the work of hundreds of researchers simultaneously. It can read scientific papers, write code, design experiments, run simulations, analyze results, suggest new AI architectures, and then start the process all over again. The researchers don't disappear. Instead, they become supervisors of an increasingly automated research engine. A new AI model improves the research system. The improved research system helps build the next AI model. That new model makes the research system even better. And suddenly, the biggest question isn't simply how intelligent the AI is. It's, how fast can the entire loop run? That's what makes recursive self-improvement so fascinating. Because if the loop ever becomes powerful enough, even small improvements could potentially compound. But let's clear up one huge misconception. The important question isn't, will AI suddenly wake up and become evil? That's a movie plot. The real question is much more practical. What happens when the process of improving AI becomes dramatically faster than humans expected? If AI can accelerate scientific research, we could potentially see faster progress in medicine, materials, energy, robotics, computing, and dozens of other fields. That could be extraordinary. But there's another side to it. The faster technology develops, the less time we may have to understand what we're building. And that's why researchers are paying attention now. Not because machines have already become autonomous superintelligences. They haven't. But because the early pieces of the feedback loop are becoming real. Right now, AI isn't sitting in a secret laboratory, building its own perfect successor. Humans are still firmly in the loop. But something has changed. For the first time, the tools we're building to create intelligent machines are becoming capable of helping us build better versions of those same tools. That's the beginning of a very unusual technological cycle. And nobody knows exactly where that cycle ends. Maybe AI becomes the greatest scientific tool humanity has ever created. Maybe progress eventually hits physical or economic limits. Maybe humans and AI end up improving together. Or maybe the next decade completely changes our understanding of technological progress. We don't know. But one thing is becoming increasingly clear. The machines aren't just learning from us anymore. They're beginning to help us build the machines that come next. And that may be one of the most important stories in technology right now. This is EDVORA. Discover more. Know more.